So today we are going to discuss recursion. Recursion is a function which calls itself, and uh, this is very important practice. How do we call the recursion as a function? Recursive function that call themselves and can only solve a base case, okay, and divide a problem up into what it can do and what it cannot do. What it cannot do resembles original problem. The function launches a new copy of itself and recursive step to solve what it cannot do. Eventually, base case gets solved and get plugged in, works it way up and solve whole problem. So this is the key philosophy behind recursion. Suppose this is a function recurse and recurse calls itself. So this function, when we are calling from main program, then it is known as normal call, okay, or non-recursive call. Fine. And the function, when this calls itself, then this will call a recursive call. Okay. So there are two different calls. Like this function calls a function of its own name, but here it will calling itself. So the way of working with recursion is, suppose this is a function and this function calls inside that definition, function 1 is again called. So now this function will solve for certain steps. Okay. So let me erase this. Initially, it start with executing the function. Okay. And then this function will call a function by same name. Okay. And after that, this will call another function. This will call not another function. This will recursively call the same function. Up to what step, up to what extent it will uh, do this call. And then again, and suppose if base case is arrived, then it will return the value. Fine. It will return the value. It is calling recursive call. This is another recursive call, and this is main call. Okay. So this is our recursive call. This is our recursive call, but this is not recursive call. So let us see the problem associated with recursion. First example is factorial. How do one can write a factorial function? So factorial of 5, suppose factorial of 5 can be written as 4 multiplied by, factorial of 5 can be written as 5 into 4 into 3 into 2 into 1. Okay. Similarly, one can also write 5 multiplied by 4 factorial. One can also write 5 multiplied by 4 multiplied by 3 factorial, and 5 multiplied by 4 multiplied by 3 multiplied by 2 factorial, and 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 factorial. And this 1 factorial is the base case actually. Or suppose I can write the 1 factorial also. Then this multiplied by this, multiplied by this, multiplied by this, multiplied by this, and this multiplied by 0 factorial. So the 0 factorial will be 1. Okay. So this becomes our base case. Fine. So let me write a program which will start doing this, which will so we need to write the base case. Okay, base case will return. It will return readable value. Okay. Uh, so let us write a function long integer factorial integer n. So what is our base case? Our base case is anything else is required? Nothing. Yes. Our base case is if what will come if n equals to 1 or this is not or n equals to 0, then it will return 1. Else return n into factorial n minus 1. So how many of you are able to understand this function? No one. Okay, not an issue. So let me show you the recursion of this particular function. Okay, so only I am discussing recursion. I'm not discussing how do we call in main program. Suppose main program will call something. Okay, so this will be duplicated and remove this portion. This portion also. Suppose a caller calls okay, factorial 5. Okay, so this n will become 5. Now whether n is equals to 1 or 0, no, it is not. So what it will do, it will do this value, it will compute this value. Okay, factorial of 5. Now what it will start doing, initially it will call n multiplied by what? N multiplied by factorial 4. Okay, this is the return. And what is the value of n? N is 5. 5 multiplied by 5 minus 1, that is 4. Now this will do once again what it will do. It will do n multiplied by factorial 3. Now again, because we are not reached at base case, this is our base case. Okay, this is our base case. If we are not putting any base case, then it will work infinitely. Now what is the current value of n? This is 3, and now this will become factorial 2. Again factorial, sorry, it is not factorial, it is the number. So this is our number. What is our number? Number is 2 and multiplied by factorial 1. Now this call will return value as 1. Okay. What is the multiplication of these two numbers? What is the multiplication of these two numbers? So this is this multiplied by this will give you 2. Now this 2 multiplied by 3, this is now 2. So 2 multiplied by 3 will give you 6. 6 multiplied by 4 will give you 24, and 24 multiplied by 5 will give you 120. So are you able to understand what I want to say? What is recursion? If anyone is having any doubt, please ask. And why recursive, recursive call will be performed. See, 5 multiplied by factorial 4. So we don't know what is the value of factorial 4. That's why it will call once again and again until the base case reaches. Okay, as soon as we reach to the base case, because now base case is available, now return value is available, uh, it is now available for multiplication. So 1 multiplied by 2 will return 2. Okay, then 2 multiplied by 3 will return 6, and 6 multiplied by 4 will return 24, and 24 multiplied by 5 will return oh, sorry, 120. Okay, so this is the way you can call, and this is the main call. This is main call. Okay, this is main call. And now let us talk about recursive call. So this is our recursive call. All these are recursive call. So how many recursive calls are there? 1, 2, 3 only. Because factorial 1, if we 4 actually. So if so 4 recursive calls are there. So this is our recursive call. Okay, so this is all about factorial function. Here we can see actual factorial is this. This is our actual factorial. Okay. This function is our actual factorial function. And here what you can see, 5 into 5 minus 1 factorial. Okay, this simply means, this means 5 into 4 into 3 minus 1, 4 minus 1 factorial. So due to this, we have created the step. Step is when, what is the factorial function? Factorial function is factorial of n can be given as, it will return 1 if n equals to 0 or n equals to 1. Okay, and it will return factorial. Sorry, this is not factorial. So is it clear? Whatever I had written mathematically? Is this clear to everyone? It will return 1 when n equals to 1 and it will return 1 when n equals to 0. Just tell me, just confirm me whether it is clear to all of you or not.
Clear, sir.
Clear. Okay.
Yes, sir.
Now let us start another example. That is Fibonacci series. Okay. What is Fibonacci series? Fibonacci series, you have heard this term in Da Vinci Code movie. Okay. So this is the series which generates the next number. Initially, we need two number. These are the base case. Okay. Base case, and it will generate all other number from these two numbers. Each number is sum of previous two number and can be solved recursively using this function fib n equals to fib n minus 1 plus fib n minus 2. And now this is our code. Okay. Using this code, what is our case? Okay. What is our case? Suppose this is a function you want to find up to nth term. So how do we define this function? This function will return n if n equals to 0 or n equals to 1. Okay. And it will return f n minus 1 plus f n minus 2 otherwise. Okay. So each and every function, whatever you can write like this. So this will give you nth term. This function will give you nth term from 0 at from 0. Okay. The term will start from 0. So this is 0, 1, 2, 3, 4, 5, 6. So all the users, different creator of this Fibonacci series program has different version, but more or less only one step is there. If suppose n is starting from 1, 1 means first term is like this is our first term, then fifth term will be 3. But if it is started from 0th term, then fifth term will be 5. So let us see what is the exam. How do we solve this? So I am writing instead of writing Fibonacci, I am writing f. Okay. So f of 6 I need to calculate. How do I calculate f of 6? So if I am going to calculate f of 6, I need more space. So let me erase this and create more space for this, and I need to write yes. So this is our main call app6. Now because this app6 is not coming under, this is our base case. So it is not following any of the base case. So what it will call? It will calling f of n minus 1, that is 5, plus f of n minus 2, that is 4. Now this will again call two things, f of 4, f of 3. This will call f of 3 and f of 2. Now this will call f of 3 and f of 2. This will call f2 and f1. This will also call f2 and f1. And this will call f1 and f0. Okay. Now this will call F2. Please mute yourself, and F1. This will call F1 and F0. Here also it will call F1 and F0. This will not call anything. This will call F1 and F0. Any other step? No. Here also one more step will come. F1 and F0. Okay. Now we have idea about what it will return. So let me write return values. So this will return n because it reaches to base case. So this will return 0. This will return 1. What is the summation of these two number? 1. Now this will also return 1. What is the summation of these two number? This is 2. Now up to this step we have done, but now let us start from this step. This is 1, this is 0, 1 and 0. Let me encircle the number. So it will return 1. So now 2 plus 1 is 3. Okay. Here this will return 1 and this will return 0. This will return 1 and this will return 0. Similarly, 1, 0, 0. No, this is 1. And this is 0. Now this will return 1. Here from left to right, this will return 1. And this is also 1. Okay. Now this will return 1. Fine. And any other thing? No. So here up to this will return 3. Here 1 plus 1 will return 2. And this 1 plus 1 will return 2. Now this 2 plus 1 will become 3. And this 3 plus 2 will become 5. Okay. And final output is 8. So you can see that the final output is 0, 1, 2, 3, 4, 5, 6. 6 term is 8. Yes or no? If you have any doubt, I can explain once again. And how many recursive calls are there? So 2 plus 4 plus 8. By is 22 and 24 recursive calls are there. Any doubt? No doubt, then I will move ahead. And because so many problems are coming from this recursion, okay? So if you have doubt, then please ask. Otherwise, I will move ahead. Now come to next problem. So this is already discussed by me. Okay. This is another version where I had not given any n equals to 1 case. Okay. Till 1 it will call something. And this is the execution of Fibonacci. So here, instead of writing this return 0 or return 1, this is nothing but this is return 0. Okay. So because of limited space, I had written like this. And once again, if it will be called, then how it will be broken? So it will be broken into F2 and F1. And finally, this F1 will return 1 because what is our Fibonacci of n is it will return n if the value of n equals to 0 or 1, and it will return fn minus 1 plus fn minus 2 otherwise. Okay, so this is a simple function. How do you calculate? And based on this, because our target is to reach up to base case. What is our target? Our target is to reach up to base case. So this is our base case. Okay. And this is our base case. So here F3 is given, F3 is divided into F2 and F1, and followed by this F2 is again divided into F1 and F0. Okay, F1 and F0. This F1 will return 1 and this F0 will return 0. Similarly, this will return 1. So if we add these two numbers, it will give you 1. This will give you 1. 1 plus 1 is 2. If we start writing 0, 1, 1, 2. Okay, so this is our third term. This is first term. This is second term. This is third. Sorry. So this is our first term. This is our second term. This is our third term. And this is, again, I had done the same mistake. So be careful. This is our zeroth term. This is our first term. This is second term. And this is third term. Okay. So be careful while writing the terms while evaluating the term. Now come to another example. This is our example of Fibonacci series. Here, this will be called inside main function. So this is our main function and the result is stored in this variable result, or you can directly call here also. You can directly call here also. Fine. And now the same execution, same thing is given. And again, I am explaining what is this function. What is this function? So this can be written in more mathematical terms like Fibonacci and equals to, it will return 0, 1 and Fibonacci n minus 1 plus Fibonacci n minus 2. What is the condition? This is otherwise. And these two will return, or you can simply write, because return n is written. So let me write more mathematically whatever written here. So this will return n for if n equals to 0 or n equals to 1. Okay, so 3 times I had explained the same function. This function is written. What is the name of function? If we highlight on particular thing, then suppose this is our main function. So this is our main function. Okay, this is our base case. So this return n will be shown here. Okay, and this base case will be shown here. And the final recursive step will be shown here. So likewise, you can write, if you write this in mathematical term, so it will definitely help you a lot. Another example of this Fibonacci, it is not true Fibonacci because it uses series also. So that's why. So here this is written in main program and the for loop is given, and for loop the value of C is, it starts from 1 to n. Suppose I want to calculate fifth term. Suppose the value of n is 5. Then this loop will run from 1 to 5. Okay. 1, 2, 3, 4 and 5. What is the value of I? Because I am passing I here. So the value of I is, initial value of I is 0. Means in first step it is 0. This is 1, this is 2, this is 3 and this is 4. Okay. Now because I plus plus is written, that's why this value is incremented. Now if you are going to execute this function is not truly a recursive function, but it will call, definitely it will call. So if I am writing Fibonacci of I, okay, so this will return what value? This will return 1. This will return, this will return 0. Fibonacci of 0 is 0. Fibonacci of 1 is 1. Fibonacci of 2 is Fibonacci of 1 plus Fibonacci of 0. And this will be nothing but 1 plus 0 is 1. Here, Fibonacci 3 is Fibonacci 2 plus Fibonacci 1. And this will give us Fibonacci 1 plus Fibonacci 0 plus Fibonacci 1. This will be replaced for 2 and this will give you 1 plus 1, 2. Okay. Now Fibonacci 4 will give you Fibonacci 3 plus Fibonacci 2. So you know that what is the value of Fibonacci 3? Actually, I need to expand this again, and this is Fibonacci 2 plus Fibonacci 1 plus Fibonacci 1 plus Fibonacci 0. Okay, this and this both are expanded. And again, if we expand this, so this will become Fibonacci 1 plus Fibonacci 0 plus Fibonacci 1 plus Fibonacci 1 plus Fibonacci 0. And this will return 1 plus 1, 2 plus 1, 3. So 3. Here you can see that the fifth term is termed as 3. So this is the problem related with, if we start from 0, what will be the output? If we start from 1, what will be the output? So I will mention it in final outcome is, it will print 0, 1, 2 and 3. Okay, it will print 0, 1, 1, 2 and 3, and it is not printed like this. It will print from /n using /n. So first it will print 0 and then followed by 1, then followed by 1. I'm taking the value from here, 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 and finally. So this is the answer. Okay, but this is from first term. If we started from first term, or if we started from 0th term, because I need to calculate fifth term. So this is not fifth term, actually fourth term, because if we start from 0, 0th term, first term, second term, third term, and fourth term. But it depends. So I will clearly mention from 0th term and from first term. Okay. If uh, if this is written, if we calculate this as first term, then this will be the sixth term. Okay. If we mention this as, 0th term, then this will be our fifth term. Okay, so I will ask the question and I will clearly mention that what will be the output. Now come to recursion and iteration. What is the difference between recursion and iteration? If we consider the iteration is like, suppose I am writing one example of factorial. Iteration, how do we write iterative step for factorial? So for integer I equals to 1, I is less than or equals to n, and I plus plus. Okay, and initial value of f equals to 1 is given. Now, what is the factorial? Factorial equals to factorial multiplied by the incremented value of I. Okay, so it will start from 1 and this will give us factorial. Okay, and let us, yes, I think this is sufficient, or if I'm writing in terms of function, then also it is very good. So better to write in terms of function so that you will be clearly understand what is the difference between iteration and recursion. So because first term is written as recursion, so let me write first iteration, because you know how do we write program using iteration. So this is our function factorial. Okay, I'm writing, I'm not doing any calculation. I am simply writing. This is not program, this is pseudocode. Okay, f equals to 1 and then putting for loop for I equals to 2 also I can do. Okay, so let me write from 2. I is less than or equals to n and I plus plus. Fine. Now this will calculate f equals to f multiplied by I, and finally it will return f. Okay, so this is our factorial function, very simple function. Now come to another factorial function. This is iteration version. This is our iterative version. Here you can see that this loop is finite. This is finite. Okay, you know that this condition will appear, then automatically loop will stop. But in case of recursion, same function I am writing. This is by iteration. Now I am writing a function recursion. So same function I had written here. And what is the output? If n equals to 0 or n equals to 1, okay, it will return 1, else return, what it will return? N into factorial n minus 1. So it will return factorial n minus 1. Now you can see very easily that there is no for loop, only base case is there. Okay, so iteration, when loop condition fails, okay, when loop condition fails, then it will automatically stop. But here termination is done with the help of base case. This is our base case. Okay, and here actually this is our termination condition. This is our termination condition. Fine. So on the basis of this, you can calculate the factorial of any number, and both can have infinite loop. If I am writing this I equals to 2, I is less than, instead of writing I is less than or equals to n, I can write I is greater than or equals to n. Then it will become infinite. Okay, but a balanced user or a standard user will never write program like that. Balance, choose between performance. If you are interested in performance, then you can write this function. And if you want to do good software engineering, then you can use recursion. So this is good software engineering practice. And this is performance. Okay. So with this, we finished our lecture on recursion, and we will start another thing. And just try to run the program. If you are unable to run the program, then please ask me. Okay, in next lecture. So today I am going to finish this lecture here. Any doubt you can ask. Yes. Anyone is having any doubt?
No, sir.
Okay, fine. So today I'm stopping here. Okay, and we will continue on Monday. Thank you very much. Have a nice day. Have a nice time.
Thank you, sir.